This is my reassessment for Standard 5, Attempt 2. In this problem, a ball of a certain mass is attached to the end of a spring of a certain stiffness. There is a string attached to the ball and it is pulled to the right so that the spring is stretched to a known length. We are trying to figure out what the unstretched length of the spring is. We also have a diagram along with the problem, and the diagram is on the XY plane. As you can see, the spring is stretched to 15 centimeters and it is pulled to the right 9 centimeters. The mass of the ball is 500 grams and the stiffness of the spring is 100 newtons per meters. And L2 here, which is the stretched length, is 15 centimeters. First, we will use the Pythagorean theorem to find x, which will complete the three sides of our triangle. To do that, we have 15 centimeters squared is equal to 9 centimeters squared plus x squared, and x would equal 12 centimeters. To get the angle between the vertical line and the spring, we use cosine theta, which is adjacent over hypotenuse, the sides, and that would be 12 centimeters, what we just found, over 15 centimeters, and that gives us 0.8. Because the ball is motionless in this problem, we know that the net force in the y direction is 0, so that means that the vertical component of the tension in the spring is balanced by the weight of the ball. So that would give us the force of the spring cosine theta is equal to the weight, mg. By algebra, we can figure out the force of the spring, and that is mg over cosine theta. So we plug in our numbers here, and the mass is 0.500 kilograms times 9.8 meters per second squared, which is the acceleration due to gravity, divided by our cosine theta, which is 0.8, and that gives us 6.125 newtons. We know also that the force of the spring is equal to the stiffness of the spring times the amount that the spring has stretched. And in this problem, we don't know that amount, but we do know that the spring was stretched to 15 centimeters. We just don't know the initial. So we plug in our numbers here, which is 6.125 newtons for the force that we just figured out is equal to 100 newtons per meters, which is the stiffness, times 0.15 meters, which is what we ended up with, the final stretched length of the spring, minus L1, which is the initial stretch of the spring, and that would give us 0.06125 meters is equal to 0.15 meters minus L1. So L1 is equal to 0.08875 meters. And in centimeters, that would be 8.875 centimeters. And that is our spring unstretched.